All right, let's get right into it. Every single day you're online, you see this tiny little icon that's supposed to tell you everything is safe. The padlock in your browser's address bar. It's become this universal symbol for security, right? But what is it actually doing? What's the secret behind that little lock? Well, in this explainer, we're going to pick that lock and see what's inside. So let's start right there. When you see that lock, what's the first thing that pops into your head? For most of us, we think, okay, this website is safe. It's legit. It's not going to try to scam me or anything. And honestly, that's probably one of the biggest misunderstandings on the entire internet. So here's the deal. We've all been trained to see the padlock and just feel a sense of safety. But what's really going on is much more specific. That lock isn't some badge of good behavior. Think of it more like a verified ID. All it proves is that the website you're connected to is who it claims to be. It's all about identity, not intent. To really wrap your head around this, the best analogy is to think of it as a website's digital passport. You know, just like you need a passport to prove you are who you say you are when you cross a border, a website needs a special document to prove its identity online. And that document, that's called a digital certificate. Okay, I know, that sounds super technical, but let's just break it down real quick. The domain identity is easy. That's just the website's address, like example.com. A public key is just a long string of data used for encryption. The certificate is the official document that links those two things together with a super secure digital signature. At the end of the day, this whole complicated system is designed to answer one single, incredibly important question. When your browser gets that public key from a website, it has to know with 100% certainty, does this key actually belong to the domain I think I'm talking to? The certificate is the proof. It's the answer to that question. Now, that public key is only half the story. It's part of a matched pair. The public key, just like the name says, is shared with the world inside that certificate. Anyone can look at it. But its partner, the private key, is kept totally secret, locked away on the website's server. And this is so important. If that private key ever gets out, the whole system of trust for that website just completely falls apart. So this all brings up a pretty obvious question, right? If a certificate is like a passport, who gets to issue them? I mean, you can't just print your own passport. You need a government to vouch for you. Well, the internet has its own version of a passport office. And they are called certificate authorities, or CAs for short. These are organizations whose entire business is being a trusted third party. Their job is to verify that you really do control a website, and only after they've proven it, they'll use their own special key to sign your certificate. They're basically notarizing it, saying, yep, we checked, this site is who it says it is. And this right here is the absolute golden rule of this whole system. Your web browser, whether it's Chrome, Safari, whatever, it doesn't actually trust any website by default. It doesn't trust Google. It doesn't trust your bank. What it has is a small built-in list of these certificate authorities that it trusts completely. The trust you see in that padlock is really just being passed down from those CAs to the website you're visiting. So how does that trust actually get passed down? Well, it's not as simple as one CA just signing one certificate. To keep the whole system super secure, it's built in layers, in a kind of hierarchy that we call the chain of trust. The process basically works like this. First, a website owner creates their key pair and fills out a formal application called a CSR. They send that to the CA. Then the CA does its homework, making the owner prove they control the domain. Once that's all good, the CA packages up the website's info and public key into a certificate, and then it applies its own unbreakable digital signature. That signature is the magic ingredient. But here's where it gets really smart. The most trusted CAs, the root CAs, they don't sign website certificates directly. Their private keys are way too valuable for that, so they're kept offline in actual vaults. Instead, they use those keys to sign certificates for a smaller group of intermediate CAs. And it's those intermediates that do the daily work of signing certificates for everybody else. So your browser has to be able to follow that chain from the website up through an intermediate, all the way back to a root that it trusts. Okay, so we've got all the pieces on the board. The certificate, the CAs, the chain of trust. Now let's put it all together and look at what your browser does in that split second right after you type in a web address and hit enter. The moment you try to connect, the website hands over its passport, its digital certificate. But your browser, it doesn't just take its word for it. It instantly becomes a detective and starts running a full background check before it allows anything to happen. And man, it is a serious checklist. Is this thing expired? Does the name on the certificate actually match the website I'm trying to go to? Can I mathematically verify the signature? Is the signature from a CA that I actually trust? Can I follow that chain all the way back to a trusted route? And hey, has anyone reported this certificate as stolen? If even one of those checks fails, bam, you get that big, scary security warning page. So you might be thinking, wow, that is an incredibly complex system for just a little padlock. And you're right, it is. But the reason all of this exists is because the consequences of getting it wrong are absolutely catastrophic. This whole system is the bedrock of pretty much everything we do online. I mean, let's just do a quick thought experiment. What would the internet even look like without digital certificates? Without any reliable way to prove who's who online? Well, the biggest problem is something called a man-in-the-middle attack. Without certificates, it would be child's play for an attacker to just sit between you and, say, your bank's website. They could pretend to be the bank, and you would have absolutely no way of knowing you're being tricked. They could just grab your username, your password, everything. And that's why this is so critical. Our entire digital world depends on it. Secure logins, online shopping, banking, private messaging, all of it would just become fundamentally broken and untrustworthy. The very idea of online privacy would pretty much go out the window. And that brings us to what is just the perfect way to sum all of this up. You should really think about it like this. If the internet protocols are the roads and highways, then certificates are the official ID cards that everyone has to carry. They are the fundamental identity layer that makes trust possible in a totally untrusted space. So let's circle all the way back to where we started, with that padlock. Now we know exactly what it means. It proves the website is who it claims to be, but it says absolutely nothing about its intentions. A scammy phishing website can get a perfectly valid certificate proving its identity as a scammy phishing website. So that lock is a crucial first step, but it is not the final word. It tells you the connection is authentic. The rest, well, that's up to you. Who do you really trust?